Morning, children. This lesson is for class 6 for the subject of physics, chapter number 3, force, from your textbook, Concise Physics, Selena Publications. It is being submitted to you on 5th of July 2021. Today, we are going to discuss the term force and its effects. The concept of force is extremely important in our daily life. The push or pull of an object is called force. It changes or tends to change the state of rest or of uniform motion of an object or to change its direction, speed, size, and shape. To make it clear, let us take some examples. Force as a push. To enter inside a room, we open the door by pushing it. If the car does not start by its engine, we push it forward to bring it in motion. In the game of carom, a player pushes the striker. A vegetable vendor pushes his cart on the rope. Then, force as a pull. To come out of the room, we open the door by pulling it. A rickshaw puller pulls his rickshaw. An ox or a horse pulls a cart while moving it. While entering into the car, we open its door by pulling it. Children, a force can be judged only by the effects which is produced by it. The effects of force are as follows. A force can move a stationary object. A force can stop a moving body. A force can change the speed of a moving body. A force can change the direction of a moving body. A force can change the size and shape of a body. Now, children, let us take all these effects one by one in detail. A force can start motion. When you apply a force on an object lying at rest, you try to make it move. For example, a player kicks a football lying on the ground at rest and it starts moving. When a horse pulls a cart, it exerts force on the cart and the cart starts moving. A girl applies force on a bicycle by pedaling it and brings it in motion. Force can start motion, but it is not necessary that a force can always produce motion in an object at rest. For example, if a person tries to push a heavy almirah, he may not be able to start motion. But if two persons together apply force, they will be able to push it because now total force is much larger, which is sufficient to bring the Elmira in motion. Now, the next effect is a force can stop motion. A force applied on a moving object can stop its motion. Like a fielder in the game of cricket exerts a force on a moving ball and catches the ball. A moving vehicle is stopped when the driver applies a force on it by using brakes. A force can change the direction of motion also. When a batsman hits a ball with his bat, the direction of motion of the ball changes. A cyclist can change the direction of a moving bicycle by applying force on its handle in the desired direction. Force can also change the speed of a moving object. Force is applied in the direction of motion, the speed of a moving object increases because you have applied force in the direction of motion. But if the force is applied in a direction opposite to that of motion, the speed of a moving object decreases. So children, if you apply force in the direction of motion, the speed of a moving object increases. But if the force is applied in the direction opposite to that of motion, the speed of a moving object decreases. Like if you push a moving cart from behind, its speed increases. Now next, a force can change the shape and size of a body. It can change the shape of a ball by compressing it with your fingers. When you squeeze a toothpaste tube so as to take paste out, its shape changes. When you stretch a string, you are applying force by your hands. Similarly, you can compress the spring by applying force inward. On stretching a rubber string, its length increases. So, we can say that force can change the shape and size of the body. Now, children, let's see what is a balanced force and an unbalanced force. If a force does not change the state of the body from rest to motion or from motion to rest, it is called a balanced force. And if a force changes the state of rest to motion or the state of motion to rest, it is called an unbalanced force. Now, do you know that standard unit of force is Newton, and it is having a symbol capital N. A force is expressed by stating both its magnitude and direction. Gravitational units are kilogram force and gram force. And you already know 1 kilogram force is equal to 1000 gram force. And 1 kilogram force is equal to 9.8 newtons. Now, what do you understand by resultant force? Two or more forces may simultaneously act on an object. The net force acting on the object is called resultant force. Now, how can we find out the magnitude of resultant force? When two forces are applied on an object in the same direction, the resultant force is the total sum of the magnitude of two forces. Like as you can see, force applied by boy A is equal to 80 newtons and the force applied by boy B is equal to 60 newtons. Now both the boys are applying force in the same direction. So the resultant force is the total sum of the magnitude of these two forces. And it is equal to 80 Newton plus 60 Newton is equal to 140 newtons. When two forces are applied on an object in opposite directions, then the resultant force is the difference of the magnitude of two forces. For example, suppose force applied by boy B is equal to 80 newtons, whereas the force applied by boy B is equal to 60 newtons. Now, as the boys are applying force in the opposite directions, so resultant force is the difference of the magnitude of the two forces. Therefore, 80 Newton minus 60 newtons is equal to 20 newtons. Now the third case. Body acted upon by two equal and opposite forces will have the resultant force 0. Such forces are called balanced forces. For example, force applied by boy A is equal to 80 Newton and the force applied by boy B in the opposite direction is also equal to 80 newtons. Now the resultant force is equal to 80 newtons minus 80 newton is equal to 0 newtons. So such forces are called balanced forces. With this topic, I'm ending up today's lesson. Thank you, children.